Hey, boys and girls, we have the finishing few pages here with your Chapter 17 Math. So we're going to go through quite a bit today, so let's get started. Math journal pages here. How would you explain perpendicular lines to a second grader? And number two is, how would you explain parallel lines to a younger brother or sister? What I'm going to do is I have a picture here of the background of my computer screen, and I hope you can see that okay. It's guitar strings and the frets on the fretboard that go along with it, okay? Now, how would you explain perpendicular lines using these strings which go this way and the frets, those little pieces of metal that go that way? Well, perpendicular lines are like the frets and the strings on a guitar fretboard on the neck there of the guitar. So what you're going to notice is that they always cross, and they always have a perfect 90-degree angle for every single one of those, okay? So that's kind of how I would explain it. It's a good way to do that for me. Perpendicular lines, maybe you want to use your TV. If you have a flat TV, the corners of the flat TV, or windows, as long as they're rectangular, and you could look at all that, and that would always be perpendicular lines. Parallel lines are the frets themselves. They go straight up and down, okay? They'll never touch. So if you could continue this line down and keep going, it would never touch, okay? Also the strings, they go straight and they would never touch. The tops and bottoms of the windows, or the sides of the windows, like the TV as well, again, they would never touch if you continued them on. Those would be parallel lines. So lines that meet are perpendicular. Is this statement true? Yes and no, right? Because when I am looking at these shapes right here, let me put a background on there so you can kind of see the difference there. But when you see the shapes here, so these lines here intersect, right? So these lines intersect, but they're not perpendicular. Now, these lines, those are perpendicular, okay? Because that is a perfect 90-degree angle. That's a square, okay? So that would be the best way I can show you that one. So technical, is this a statement true? Now, if it's going to be true, it has to be true all the time, right? So, lines that meet are perpendicular, that is false. Not all lines that meet are perpendicular. There are sometimes they are, so it's partially true, but it's got to be all the way true. All right, here we go. Study the figure CD and EF. So line segment CD is not perpendicular to line segment EF. How would you show that they are not parallel? So parallel, like this one here, just goes right on the background, and it will go on forever either way. But this one here, it's going to hit it. They're going to run into each other at that spot right there, okay? So how would you show that they are not parallel? Well, I could continue this line down and have it hit, okay? Let's go on now to put on your thinking cap, and I brought the good old geoboard. Love these things. Okay, geoboard is going to help us out with these next few questions. Now, our first geoboard question is asking us a shape, draw each shape with dot grid paper, and I'm using this. So, a shape with 5 sides and 5 angles. Well, that sounds like the pentagon to me, doesn't it? Okay, so I'm going to put one up here. We'll just kind of come that way a couple, and down here, and over there. Okay, 5 shapes, or 5 sides and 5 angles. 1, 2, 3, 4. There's 5 sides, and there's 1, 2, 3, 4, 5 angles. Okay? Now, number 2 says a shape with 3 sides and 2 angles less than a right angle. Okay, so I'm going to put this one down here and there. Now, when I look at this triangle, 3 sides, so we knew it had to be a triangle right away, right? So with my 3 sides, I see this one here's a big angle, okay? But this one's just a little angle, and this one's a little angle. So those are both less than a right angle. They would have to be like that to be the right angle. And they are not like that. They're like that. So there you go. Number 3, a shape with 4 sides and an angle greater than a right angle. So let's go 4 sides let's see, how many do we have here? We have 1, 2, 3, 4. Okay, we got 4 things. That's a 90-degree angle, a 90-degree angle. This one is less than 90 degrees, and this one is greater than 90 degrees. Okay, or greater than a right angle. Number 4, a shape with 7 sides and 7 angles, 3 of which are right angles. Let's see. Let's go something like, how many sides do we have? 1, 2, 3, 4, 5, 6, 7. Okay, there's 7. And 3 right angles. So here's a right angle here. Here's a right angle. So there's 1, there's 2. This is a right angle, 3. This is greater than, okay, perfect. There we go. 7 sides, 7 angles. Okay. Let's go here to number 5. Name 2 pairs of perpendicular line segments. All right. So my perpendicular line segments now. There we are. Perpendicular, meaning straight up and down or straight side to side. Like side and up or side and down, however you want to picture it. So when I'm looking at this, I see AD, okay? So AD and EC are perpendicular. I also see that BE, I'm going to put BE on this side, and AC are perpendicular lines. This one here, those 2 are both 90-degree angles, and these 2 are both 90-degree angles for the AD and EC. So number 6, we have name 4 line segments parallel to NM. So there's OP, OS, PS, and QR. So as we're looking at all of these lines that are straight up and down are going to be parallel to MN. This one's tricky because you think of it as maybe OP or maybe OS or something. QR is pretty simple, you know that one is. But this one's tricky that there's actually 3 different line segments found just in this part of the problem. So hopefully you see those, right? We got OP is just the little one here. And then we have OS, which is the big one. And we have PS, okay? Number 7, how many pairs of parallel line segments are in the diagram? So when I'm looking at this, I see here's one that goes straight across, and here's one that goes straight across. So I'm going to use a tally mark. There's one, okay? I see this diagonal and this diagonal. So there's another one. And then I see this straight up and down, and I see this straight up and down. So there's another one. Now, I don't know, I'm not thinking that it's cutting every single one of these into a different line segment. I think the whole line segment is from this spot to this spot. Okay, otherwise there's going to be a lot of them, and I don't think that's the case of what they were trying to get. They were trying to get 1, 2, 3, 4, 5, 6. Okay, so there's 3 pairs of line segments. All right, put on your thinking cap. Here we go. Draw shapes on a grid paper. So I'm going to get this one back out again. Draw a triangle with a right angle. All right, so here's my triangle. Here's my right angle right here. That's the perfect up and down or 90-degree angle. Okay, and those are not. Now the second part of that question is, can you draw a triangle with 2 right angles? No, you cannot. It is impossible. Okay, because 90 degrees and 90 degrees, 90 plus 90, or 9 plus 9 is 18, so 90 plus 90 is 180. Every triangle has 180 degrees, so that would be just impossible. All right, number 2. Draw a shape with 4 sides and 2 right angles. Okay, let's see here. 1, 2, geez, this is tough, huh? 1, 2, 3, 4. Okay, so these two are both right angles. These two are not. What do you notice about the other angles in the shape? Well, one's smaller than 90 degrees and one is larger than 90 degrees, right? Is that what you were seeing? Yeah, pretty nice. All right, number 3. 5 students are walking to school from their houses. Look at the map. Okay, so here's our road. These are the different students' houses. Which student's house is nearest to the school? Well, that'd be student C. And go straight up and down. You're closest. You're 1, 2, 3 pieces away from it, right? Draw a line segment to join the student's house to the school. What do you notice about this line segment? It is a straight line, and it is 1, 2, 3 sections long, and it's also perpendicular to the road. Okay? Number 4, here's the tricky one. Okay? We have the challenge. This pattern is made up of perpendicular line segments. The first pattern has 1 right angle, so pattern 1 has 1. The second pattern has 3 right angles. The third pattern has 5 right angles. So the fourth pattern, if we kept this thing going, would have 7. 5 would have 9, 6, 11, 7, 13, 8, 15, 9, 17, and all the way down to 10. How many right angles will the 10th pattern have? So 10 would have 19 right angles. All right, boys and girls, way to work hard with your chapter 17 angles and lines. I always thought that was one of my favorite things to do. Moving on to like a drafting class when I got to high school, I was able to go into the wood shop and kind of create some things, make some cool looking drawings that were perspective related because of the lines and line segments and angles. And it was, for me, it was very enjoyable. I loved it. And I hope someday maybe you'll get to that point where you get to enjoy some of that too, kind of some architecture, engineering, maybe stuff. But anyway, I hope you guys had a great time, and we will talk to you later. Bye.